We know that Jupiter has an atmosphere made up mainly of hydrogen and helium. Europa, a moon of Jupiter, has a very thin oxygen atmosphere, and HD 209458b, a Jupiter-sized exoplanet orbiting the star HD 209458, which is 154 light-years away, has an atmosphere that contains hydrogen, carbon, oxygen, sodium, carbon dioxide, methane, and even water vapor. All this even though we haven't visited any of these places to directly sample the air. But we don't need to. We can study the air on other planets, moons, and exoplanets just by looking at them. In particular, by looking at light that bounces off or passes through their atmospheres, because when you shine light on a gas, the molecules absorb and scatter different frequencies of that light in different amounts. If we then split the transmitted or scattered light apart into its constituent colors using a prism or diffraction grating, we can see a molecule's light absorption fingerprint, or its light emission fingerprint. This is hydrogen. This is nitrogen, oxygen, methane, carbon dioxide, water. So when we look at the sunlight bouncing off of the atmospheres of planets and notice spikes of certain heights in certain frequencies, we can carefully match those to the known fingerprints of gas molecules, and learn not just what gases make up the air, but even their relative abundances. In fact, we don't even need to be able to see a planet at all to learn about its atmosphere. Many exoplanets have been discovered because they pass in front of their parent star, which we see as a dip in the overall intensity of the star's light. But if an exoplanet has an atmosphere, the gas molecules in its atmosphere will block some frequencies an extra amount, according to their molecular fingerprints, and we can do the same fingerprint matching process as before. And that's how we know what's in the atmosphere of HD 209458b. Of course, in practice, it's pretty darn challenging to use molecular fingerprints to study exoplanet atmospheres, because air is thin, so the fingerprints are super faint and we need big sensitive telescopes and spectrometers, and because atmospheres are complicated and their fingerprints can be ambiguous or hard to match, and because different parts of a single star emit different amounts of different colors of light, so a planet's effect on the star's spectrum will depend on which part the planet passes in front of. But all of these difficulties can be dealt with by clever astronomers, and thus we have been able to figure out what the air is like on planets hundreds of light years away that we can't even see. Hey there, and thanks for watching. This video was made possible by NASA's James Webb Space Telescope project at the Space Telescope Science Institute. Now, the Hubble Space Telescope and other observatories have been able to determine the atmospheres of some exoplanets like big gas giants, but the James Webb is going to be so much more sensitive that it'll be able to tell the atmospheres of rocky planets like the Earth, and that is really exciting. So again, thank you to them for supporting this video, but more importantly, for doing awesome science.